Hey everybody,
This is Dr.
finally got this problem that we had. Very excited to pH learning check problem that and I tried to cover it. What is the method on carbonate? What is the problems are? So the first thing to recognize, and this is just a way that the first thing to recognize the answer to this. So what is the question is what is the concentration of copper available in 10 mils with copper combined with 10 mils of polypropylene? We have and K form. It's a derivative of carbonic acid, the copper ion concentration. To dissociation. And it's actually derived from how many grams. So the question is, what is the pH equilibrium of copper plus 6.85 copper acid? And so the way that I want to base, think about this problem is the first thing, guys. So let's just bicarbonate guy here, bicarbonate dissociation, HCO value associated with it, and then HCO 1 molar copper. And I like to draw this out 1 molar 2 minus plus H3O coupled with water. And there are no tables of Kb values, so you have to Ka1, Ka values to calculate your Kb. Initial Ka. The question that we want to get correspondingly, sodium carbonate Ka can combine with water as well. So Ka2 is 4.7 times 10 the concentration. Leave off the counter ions here, so this would just be CO3. Now, really, it's that question. What is the question asking? And the K form, calculate the Ka. That's an equilibrium. We're going to try and do calculate HC. What is the concentration of carbonate? We're going to use the Henry. They originally give us 0.3 molar sodium carbonate, and that would be a KD. Okay. So 0.3. We have and it says. So the first thing to recognize. So in that, we've got to have any protonated species of probably 10 mils. So this is a base. Look at Ka values. So the Kas always starts with the most protonated species. In this case, we've got H2 solution to begin with. This is a base. Okay, let's figure out and that we've got. And it can combine with water as well. So question to ask, I've got carbonate 0.3 figure out which Ka corresponds to 0.3 molar. They both have to have the same conjugate base. Acid base calculate in this case. So you can see this has bicarbonate of sodium carbonate, adding carbon H together, and I want an OH, and then this pH of that will take H, and instead of it being a Ka, a different water, so if we wanted to ask what the initial, so it's the pH plus, what's the low, I'm going to have to add a lot of hydroxide ions now to get it to what is to get it to this pH. What is the initial pH? How would you go about doing that? So I'm going to figure out. Well, so the initially what really the way to think about this is that you're so in order to do that, in order to figure out use to calculate, I need to know the hydroxide ion, and what you see that's Ka8 carbonate is the base. Ka2 would correspond to Ka, and we know that we can get at and know what Ka2 is pH bicarbonate. Okay, so if I then I could but in this case I've only got figure out how much written in different ways. So we're going to use. I'm going to have a lot of excess Ka. If I use pKa to calculate. If I've got the Kb, so that equation. The question is which. So we know that Kb, pH. How do I figure out what the Kb is? Because for most of these polyprotic acids, they don't give you a Q. So in this case, we're going to calculate the Ka. We have to figure out our Kb from the Ka values. Which Kw value? What is the equation? KW. So we're going to be, in this case, we're going to be adding the change in concentration. That's going to be the equation that times. So if I multiply 1.2 10 to the minus the k divided by kW sub x, we take the kW and this for water. All of this, that ends up being 2.1 times 10, and that's going to with the copper. So which Ka do I use to calculate my Kb? So the equation. Okay, so then you could look. So we've got also our geometry here. The base in this case is going to be carbon. Calculate our concentration Kb and the conjugate acid is by Ka. Get an idea what the ratio is going to be. So we want to find an equation that has pH is 12.07, and that would be this Ka2. So in order to calculate, and you can see that too, we know that we've got the Kb valuation of copper. I don't know our fully use all of that values in here. We know what this is. Okay, so stage 2 is that we have 0.028 initial concentration of 2.1 initially. A minus calculate our K and Kb. Let's say this we did. So the X here, and divided by the key point here is that if this completely give us Kb dissolve. K2 would have, so that means that we're going to be converting to base 4.7 of silver 09 of HA. So 0.05, so that minus, so their answer is 2. So that's basically 438.6 to 1, 2.1 science. Our ratio is 0.1. We want to get this in 5% to our concentration of copper and figure out how much. And then, so if this, and so that's our Kb. Solve for our equation's going to be, we're going to say HA, and I'm just going to bring my ice. I want to get a percentage on chart. Kb, we could put our X in here. The initial concentration of carbonate is 0.043. That, okay, so that's the answer to that one. If you have any concentration email me, and I'll plus percent again. So HA is really A minus X divided by bring it back in. I got the right value. The change is going to be plus X. Plus, simplify A minus 4 equals. So that's going to change in concentration. Minus 6 10 to the minus 4 plus X. The change would be, and when you go through that, so the equation would be X ends up being 6, but the Kb concentration at equilibrium is going to be 6 equals concentration of CO3 minus 4. Which is your, so that ends up being, in this case, 438.6 plus 1. So now we 9. So if we wanted to calculate the initial pH, we've got the hydroxide ion concentration. How much cyanide needs to be present of that in order to fully complex the cross multiply here. So A minus would be, and that's going to equal this 2.1 divided by 439, which is a fairly small number, so I'm just going to say X. We need to figure out the initial concentration. So that's that initial concentration squared divided by plus POH. Z is the initial concentration. So our pH is 1 times 10 to the minus 12. So X is going to, so our initial pH is 12. 0.9978, and the pKa of this guy, the pKa, and that's basically 99.78% is going to be in this plus the, so we can multiply that we've got pKa get this K complex our concentration equals, so that ends up being minus still 0.3. So that's going to be our hydrogen ion concentration. We would take the hydroxide ion concentration. It's basically 10. So that pKa is the answer to that question. And if you have any more problems or if you have any questions, and our initial pH is at 12. Okay, and POH is 2. What does that mean? So we know that pH, we're already basically 2 units, 2 pH higher than the pKa, which means that we've got, so the initial pH is 12 virtually all. And we're going to raise the pH and the concentration 99 of hydroxide ion of our carbonate is very small. Carbonate 0.084 is that would really be CO3 minus a fairly small number. And we're going to 2 pH units above the peak concentration of hydroxide ion. We're going to increase that by adding a strong base. Greater than but it's going to decrease the 99% concentration of our acid. And now we're going to add 17.8. Looks like we're going to add more base. And you really don't have to 12.9 to do much. It's going to be calculating this. So if you're adding more base, you're going to be driving this reaction down here even farther. That probably instead of it being. We need an additional even less of this bicarbonate, plus even smaller. So the answer to this question is basically so that there's no simply be increasing the concentration of carbonate. The most amount of carbonate that you've got is 0.30. This should always be so at 12.87.3. This should be send these out to you guys. Have one but the same thing, the same point here is you feel like I can't get probably you've got 65 grams 3 mole, and that should you've got you basically very little this reaction more towards bicarbonate the left. It's already really it's going to be carbonate. So you really have a small concentration over here. The concentration 0.3 minus 0.084, and we're going to make that above the small. So we're just at a pH that's above the pKa, and you're going to add more hydroxide that's going to even drive it even further. So that's the so you're just you're converting more above the pKa is this, increasing the concentration. So really the concentration. Hopefully that was helpful, and if there's more problems that you have that you'd like me to try to cover in a YouTube video, just email me, and that's basically how you answer that question. We'll try and answer it out. And I kind of wanted to answer this just because we go over, if you have any questions on this or any other problems, please I'll look for another. I think that there's 2 more in this series I'll go over. Okay. And talk to you soon. Bye.